In this video, we're talking about limit. So the first two limit laws were stated in two important limits, and we are going to repeat them in this video. So these basic results, together with other limit laws, allow us to evaluate limit of many algebraic expression. So let's look at these two limits laws. So the first one is lim of x equal to a as lim is to a, and we have the second one is lim c equal to c as x matches onto a. Okay, so let's take this one as 1. We are taking this one as 2. Okay, so let's look at some examples. So let's say we have lim of x as x matches to 2. And another example, so let's take this example A and this example B. Lim 5 as x matches into 2. Okay, so the first one, A, we can see that the limit of x as x approaches A is so the limit of x as x approaches A is lim x equal to 2, then x approaches 2. Okay, then the B, the limit of A constant, that's the constant, as lim 5 equal to 5 as x approaches 2. Very easy. Now we take a look at the limit laws, the individual properties of limits. The proof that these laws hold are omitted here. Okay, so we are going to look at some laws here. So let's take f of x and g of x be defined for all x, where x should never be equal to a, over some open intervals containing a. Okay, so assuming that L and M are real numbers, so we're going to take L and M to be a real number such that lim f of x should be equal to L as x approaches A, and also take lim g of x should be equal to M as x approaches A. So we are going to let C to be the constant. So take note, C is the constant. Okay, then each of the following statements are going to be hold. So let's take the first one. So the first one is the sum law of limit. Okay, which is lim f of x plus g of x as x approaches A to be equal to lim f of x plus lim g of x. It should be equal to L plus M as x approaches A, x approaches A. Okay, now let's look at the difference. So difference, so these two. So difference law for limits. So lim f of x minus g of x. Okay, so we have should be equal to L minus M. Okay, as each of them x approaches A, x approaches A. Then we look at the multiple. So the multiple law for limit. So this is constant multiple, so it's a constant multiple law for limit. So we have lim of c, because we still constant is c, right? Then f of x should be equal to c multiplying lim of f of x should be equal to CL. Okay, as each of them approaches, x approaches A, x approaches A. Okay, then let's look at the product. For product law for limit. So that one we are going to have lim as x approaches A of f of x multiplying or dot g of x should be equal to lim f of x dot lim g of x, okay, should be equal to L dot M, as each of them x approaches A, x approaches A. Okay, then let's look at the quotient law for limit. So 5 quotient law for limit. So quotient law for limit, so we're gonna have lim f of x divided by g of x as x approaches A to be equal to lim f of x as x approaches A divided by lim g of x as x approaches A to be equal to L over M, for M shouldn't be equal to 0. Okay, so these are all laws. Let's look at the last two. So 6, we have power law for limit, where we have lim f of x exponent n as x approaches A should be equal to lim as x approaches A f of x exponent n should be equal to L exponent n. Now for this, for every positive integer is n. Okay, let's look at the last one, which is the root law for limit. So for this one, we have lim x approaches a, the root n, then f of x should be equal to the root n, then lim x approaches a, f of x should be equal to root l n. Okay, now for this one, for all l, if n is odd, and for l greater than or equal to 0 if n is even, and for f of x should be greater or equal to 0. So let me state that. So for this one right here, l if n is odd, and when l is greater or equal to 0 if n is even, and f of x is greater or equal to 0. Okay, so these are the conditions attached to this law. Now let's look at some practice applying to these laws. Okay, so first example that we're gonna use that. So example 1. So lim into bracket 4x plus 2 as x approaches -3. So let's apply the limit laws one step at a time to make sure we understand how they work. Now we need to keep in mind that the requirement at each application of the limit law, the need limit law must exist for the limit law to be applied. Okay, so lim 4x plus 2 as x approaches -3, okay, should be equal to lim 4x plus lim 2. For each of them, x approaches -3, x approaches -3. Okay, so here what we did is that we apply the sum law. That's what we did here. Okay, now when we are done here, the next thing that we will do here is to apply the constant multiple law. Okay, so that will be 4 dot lim x plus lim 2, okay, as x approaches -3, x approaches -3. Okay, so the 4 is the constant c. Okay, we have the lim x. So here we apply the constant law for limit. Okay, then when we are done, we come in, substitute our x. Okay, so we will have 4 dot -3 plus 2. Okay, so after applying all the basic laws, when we do this, we should get -10. Okay, that's our answer. Now let's look at this one. Example 2. So with example 2, we have lim 2x squared minus 3x plus 1 on x exponent 3 plus 4 as x approaches 2. Okay, so to find this limit, we need to apply the limit law several times. Okay, again, we need to keep in mind that as we rewrite the limit in terms of order limit, each new limit must exist for the limit law to be applied. Okay, so it's very simple condition. So now let's start. So starting, let's have lim of 2x squared minus 3x plus 1 as x approaches 2 on lim s cubed plus 4 as x approaches 2. Okay, so here what we did here, we applied the quotient law, making sure that 2 exponent 3 plus 4 shouldn't be equal to 0. Okay, that's what we are trying to make sure we do. Okay, now the next thing that we have to do here is to apply the sum and the constant multiple law at the same time. Okay, so we have that constant of 2 multiplying lim of x squared minus 3 dot lim of x plus lim of 1 as each of them x approaches 2 and x approaches 2 on lim of s cubed plus lim of 4 as x approaches 2. Okay, then when we are done, let's apply the power rule because we have some numbers that we need to apply the power rule here. So let's look at that. So the next step is 2 dot multiplication to bracket lim of x approaches 2 exponent 2 minus 3, okay, dot lim of x approaches 2 plus lim of 1 x approaches 2 all on lim of x approaches 2 exponent 3 plus lim of 4 x approaches 2. Okay, so here we just apply the power law for limits. Okay, now our last thing is, after applying all this thing, we have to simplify it by just substituting the x approaches 2, which is the number for x, into the or where we see x. Okay, so let's just do that and simplify. So we have 2 multiplying 4, okay, because when the x is 2, then raise the power 2 is 4, so that's how we had 4 minus 3 multiplying 2 then plus 1 on 2 exponent 3 plus 4. So 2 times 4 is 8 minus 3 times 2 is 6 then plus 1. Okay, so this is this one will be this plus 2, so 3. Okay, so 3 on this is 6 plus so 2 exponent, okay, sorry, 2 exponent 3 gives 2 times 2 times 2, which is 4 times 2, okay, which is 8 plus 4, which is 12, so 12. Therefore we have 3 on 12. Then when we break it down, we should get 1 here, 4 there. So the answer is 1 on 4. Very simple. So here we can see that after using all the limit laws, we arrive at this answer. It's very, very simple. Okay, now let's try this on your own. So using the limit loss, solve this. Lim 2x minus 1, the root of x plus 4, as x approaches 6. So try this on your own and put your answer under the comment section. If you have any question too, you can also put it under the comment section. So this is the end of this video. I'll see you in my next video where we talk about limit of polynomial and rational functions. Thank you for watching.